Hello, we're going to talk about how to find out if an ordered pair is a solution to a system of inequalities. We did look at before whether or not an ordered pair was a solution to a linear equation, and the difference here would be that when we were doing this before, we just looked at if that ordered pair was where the lines crossed. This time, what we're saying is that because it's an inequality, there is a solution set, meaning there's more than one right answer. And we're just trying to find out whether this ordered pair is one of the right answers. So with that said, our process is pretty much going to be the same, but instead of having an equal sign, we're just trying to figure out whether or not the ordered pair makes the statement true when we plug it or substitute it into each inequality. So what does this look like? I'm going to take 1, 10, so 1 is going to be x, 10 is going to be y, and I'm going to substitute those values in for x and y, and I'm going to see if the inequality comes out true. So I'm going to say 10 is greater than or equal to 1 plus 9. 10 is greater than or equal to 10. Is that a true statement? Well, 10 is not greater than 10, but 10 is certainly equal to 10, so that's true. So then we're going to do the same thing with the second inequality. So 10 is greater than 3 times 1 plus 2. 10 is greater than 3 plus 2. 10 is greater than 5. Is that true? Well, absolutely, it is true. So we would say yes, 1, 10 is a solution to this system. It's just one of the right answers. There are several more, but they didn't ask us to check for those. Now, here, let's try the same thing. We've got, is 1, 8 a solution to the system of inequalities? So we've got x and y. Well, 8 is greater than 6 times 1 plus 2. 8 is greater than 6 times 1 is 6 plus 2. 8 is greater than 8. Well, 8 is equal to 8, but not greater than 8. So this is a false statement. So because this is a false statement, we would say no. This ordered pair is not a solution. In order for us to say yes, both statements have to be true. If one statement is false, then the whole thing is false, and you don't even have to check the other one. So that's how that works. So let's go on. We've got 2 is x, -1 is y. So we want to know, is 2, -1 a solution to this system? So we're going to put -1 greater than or equal to 2 minus 3. -1 greater than or equal to 2 minus 3 is -1. Well, is -1 greater than -1? No. But -1 is equal to -1, so that's a true statement. So now we have to test the second one. -1 is greater than -1 over 2 multiplied by 2. And I'm going to go ahead and make this integer into a fraction by placing it over 1, since I'm multiplying by a fraction, minus 3. So -1 is that greater than, well, a negative times a positive is a negative. So we've got -1 times 2 is -2. 2 times 1 is 2. And then minus 3, and I'm going to go ahead and simplify this. So this is -1 minus 3. So negative 1 is greater than, well, negative 1 minus 3 is negative 4. So now, here you have to think about the number line. Where is negative 1 in relationship to negative 4? Well, negative 1 is to the right of negative 4, because remember, on the negative side, the closer the number is to 0, then the greater it is. So if you think about the number line, right? This, let's say this is 0, and this is 1, and this is 2, negative 1, negative 2, negative 3, negative 4. Well, negative 1 is obviously greater than negative 4 because it's closer to 0. So this would be a true statement. So yes, 2, negative 1 is a solution to our system of inequalities. Now I want you to go ahead and try the your turn, and I'll be right back. All right, here you have the answers to the now it's your turn. I hope that you found this process simple. If you need any help at all, please, please, please don't hesitate to ask. I'm here to help you if I can, and if you let me. I'll talk to you later.